say this again, I said this last week, there's absolutely no reason for anybody to be sitting up on the balcony while there are seats down here. There's another reason for that, which is we've actually managed to persuade college to put in desks down here. It's impossible to do that for the seats on the balcony. So if you're up there and you're just hiding from me, then it's a bit silly because you're not getting a very good experience up there. And whereas I can get to anywhere down here, I can't get to up there. So you can't ask me questions, you can't do anything about getting help from me. So if you're going up there, then you're making a very explicit decision to pull out of this lecture, essentially. Since the algorithm for signing the register didn't work very well last week, you didn't seem to be able to follow it, I'm going to try a slightly different algorithm, which is we've got one register here which will now go down this side, so just make it go weaving down this way. I've got a register that will weave down this side, and then more registers over the other side to do the same thing. Again, make sure you sign it. If you don't sign it, you weren't here. There's a record down the column of how many classes you haven't signed. So that's both lectures and labs. My experience is that when that number gets to 4 or 5 over the whole term, people's grades drop off a cliff. And that's just from plotting graphs of people's results at the end of term. So I don't claim I know what the causality is. Oh, and given you might want to be present, there's a register for up there, but I repeat, if you've gone up onto the balcony when there's loads of seats down here, you're basically opting out of this lecture. You ain't getting a desk to work on, you ain't getting any opportunity to talk to me. Right, very important announcement to start off with. Your first assessment that you cannot miss is coming up. It's going to be in week 5. At the moment I'm trying to plan it to be in the lab, so it will be in your allocated lab of week 5. So, some point on the Tuesday. If you miss it and don't do that, you essentially fail. So you get 0 for the coursework. That doesn't fail the whole module. You could get 90-odd% in the exam and still manage to pull through a pass, but it's not a good idea to do it. If you do miss it because you're ill, you'll need a doctor's note. If you miss it for any other reason, then you'll need documentary evidence that's good enough to explain to the Extenuating Circumstances Committee why you weren't able to make it to the test. That basically is the way all coursework works. If you miss it or you miss a deadline, then you're liable to get 0 unless you put in some kind of extenuating circumstances. That form ultimately has to be handed in at the ITL office. I don't have anything to do with it. They just tell me after the fact that this is a person that had a good reason for missing, so I shouldn't give them 0. Okay? So you cannot miss week 5. And what will it be on? It will be on everything from the workbook 1. So there are 3 parts to the workbook. So midterm test will be testing part 1 of workbook, i.e. that's how much you've got so far. So it's basically units 1 to 4 of the module on the QM Plus page. And let me just stick that so it appears on the video for a moment. Get these the right way there. Okay, so what we're going to look at today is essentially overlap from Unit 2 into Unit 3, mainly Unit 3 stuff, What does that mean? We'll start to look at what records are, and particularly look at methods in a bit more detail, and use records as one way of looking at sort of fairly simple uses of methods. In particular, you should by now understand how to call methods that act like procedures that just do something, but also ones that return results. And we're going to be looking at ones where you need to pass some information to the method for it to do its job as well. And then we're going to look at decision making, how you get programs to do different things depending on what a user types in the second half. What I'm going to start with is something that kind of goes back to what we were looking at last week, but taking it slightly further. And this is something that you need to be able to do for the midterm tests. That's trace dry run programs. So what you should be able to do by now is write simple programs that can manipulate simple values, use different types of values, so declare variables that can hold different types, strings, integers, booleans and so on. You should at least understand the mechanism for that. What we're going to see, so I didn't touch on it at the end of last week, but what we mean by records is actually a way of creating your own new types, so you can add to the types that you've got. And you've got to be able to obviously be able to explain these programs and dry run them as well. I'm not sure whether I put that on that particular slide, but everything we do, you've got to be able to write programs, you've got to trace programs, which just means take a program and understand it, and you've got to explain all the concepts. And that's the sort of thing, those three things are the things I'll be testing on the midterm test, the exit test, and in the exam at the end of the year. So let's start by a recap of last week that is also going slightly further and giving you a way of doing this. Let me just find a pen. So this is kind of like the little trivial code we were acting out at the end of last week. Obviously, if you're given some code, what I'm asking you to do is to be able to work out what it does. And what we did there with the people standing with boxes and labels and so on is working out what a piece of code did in an elaborate way to make sure you kind of understand all the steps. And I'm going to give you example questions to answer, which are little fragments of code like this, and you've got to work out what they do. And I think there are examples like that actually on the progress test of last week. When they're really small and simple, you can probably do it in your head if you understand the concepts well enough and you understand how things work. When they get to more tricky things, you can't do it in your head, or at least if you do it in your head, you're almost guaranteed to make mistakes at some point in your life. So you need an organised way of doing it. And what you can't do in an exam for sure is get a bunch of volunteers up and start getting them to hold boxes. So how do you do it? Well, you can do it on paper. One of the easiest ways is to do what's called a trace table, which is actually step through the code line by line in the way that we did last week, but do it by keeping track on paper. And you could sort of draw pictures of boxes, but an easy, organised way of doing that is to draw a table. And this approach sort of works with all sorts of programs, not just the sort of simple ones we're looking at here. So I'm just going to do it on a fragment. And this is the sort of thing you probably ought to do when you're trying to debug code. If your program doesn't do what it's supposed to, it runs okay, it's got past the compiler, and you can run it, but it does the wrong thing, and you can't understand why it does the wrong thing, or why it crashes. Stepping through it line by line like this is one good way of actually finding bugs, working out what's going wrong. So it's not just an academic exercise. But anyway, suppose I want to work out what a little fragment of code like this does. What I'd do is I'd start drawing a table. So what we do is we keep track of where we are. That's sort of the baton being passed around. What line are we at? Well, we start at the top, and the first thing we do is that it's going off. Let me just adjust that a little bit. So. Okay, so we're going to start executing the first line. What does that do? It creates a variable called x. So in the sort of language I was using before, that's create a box, create something to store places. Now what I'm going to do is create a column of a table, and I'm going to label that X. And that column is going to keep track of the current value in that variable. So what's in it at the moment? This statement declares it, but it doesn't initialize it. It doesn't put a value there, so I just leave that blank. If we tried to get a value out of it, essentially we'd crash the program at that point, but actually the compiler wouldn't let you write an instruction that tried to get a value out of a variable before you'd put anything in. But we've created a box, and then that's finished that line. It's an X, and you might want to keep track of what's supposed to go in it as well. It's an int. And then the next line we go on to says int y. What does that do? That says create me another box, create me another variable, so create another column to keep track of what goes on there. And then we move on, and what does that say? Pronounce it for me. What's the way I say you should pronounce that? Not x equals. Shoot yourself if you're saying x equals. X gets the value 1. Something that makes it clear that it's a command that x is getting that value. X is a variable, 1 is a value, you are putting the value 1 into the variable x. So how do we do that in this table? If it was a box, we'd just drop a 1 in the box. Here we write a 1 in that column that says now the current value of x is 1. And that's all that line does. Go on to the next line, it says y gets the value 2. So what does that involve doing? Find the column for y and put a 2 in it. All we're doing is using the columns to keep track of what's where. So what we've got now actually is a bit of code that's the sort of thing people write if they want to swap values in variables when they're novices. They think this will swap values around, but actually it doesn't. So let's see it. We sort of talked about this at the end of last time, I think. So this says x gets the value in y. So what does that actually mean? It means, first of all, go to y. Yeah, whatever is on this side, you've got to evaluate that. It could be just a value, it could be a variable, it could be a whole calculation you have to do, but whatever it is, it could be a method call, whatever it is, it gives you a value. So you go away and evaluate that bit of code first, and it will come back and hand you a value. In this case, it's just a variable, so how do you get the value? You go to y and have a look what the last value placed in y was. Anything else will have been scrubbed. It's always the last thing that went in there. So 2 is in y at the moment. So essentially, you're now holding the value 2, and you're wondering what to do with it. And this tells you what to do with it. It says x gets that value. So what does that mean? We put it in to x. So the next line of x, we put the 2, we've taken a copy of y, and now we put it in x. Now what happens to that 1? Gets destroyed. That's me stamping on it, eating it, tearing it up. So we can just cross it out to make it clear that it's gone. And that's one of the most common mistakes people make when they're dry running this, even though you're clever people who know how to program. If you're just looking at the program, it's easy to get in your head, oh, it's 1 that's in x, because it says x has got the value 1 in there, it's in your face that x is 1. But it's not now, x is 2, it's changed. And that old value has just been scrubbed, so cross it out so that you can't get confused. And so now we've got 2 in x, and we've still got the 2 in y, because this command doesn't say anything about changing y. And then we go on to the next line, so that was that line. Now we go on to the next line, y gets x. So we go to x, find out what's in there, it's 2, so now we're holding a copy of 2. And what do we do with that 2? Well, this says put it into y. So we put the 2 in y, and in doing so we destroy what was already there. Just so happens the same value was already there, but that old value is taken out essentially first, and a new value overwritten over the top of it. The new value is the same thing, so it's left looking the same thing. So at the end of this, what are the values? X has value 2, and y has value 2 as well. Okay? So by stepping through it line by line, we've basically worked out what it does. And this table just is there to help make sure we don't lose track of the values of things. And essentially, we're doing exactly what the computer's doing. We're just using the table as our scratch memory in the way that the computer uses memory itself. Okay? So you're actually executing the program just as the program is. You're just executing it in your head and on the paper. Now, if you're executing it all in your head, you're relying on you having a memory as good as a computer, and no human has a memory as good as a computer, which is why you can use paper to get the same effect. Okay? So that's a very simple way. When I ask questions to do dry running and give you code and say, what does this piece of code do, it's highly unlikely all I'll be asking you for is the answer. So that is the answer of what this code does. But a question I ask you about it in an exam or a test will ask you for a justification as well. So I don't just want the answer because you could have just guessed the answer. What I want is you to show me you can work it out. If you do it all in your head and write down the answer, you may not get any marks at all. So this is one way of you giving me a justification. Another way would be to write out kind of sentences in English and write out an argument, an English argument, as to why the answer ends up being x has value 2 and y has value 2. You might find in some situations that's easier, but this is probably the quickest way of giving me a justification that also helps you get the answer right as you go along. Okay? So anybody got any questions? Do you understand essentially what you do given an example like that and asked to dry run or trace it, work out what it does? What we're doing here is working out that's what it does overall. It sort of attempts to swap the values but fails and just leaves them both the same. This is sort of a version of step by step what it's doing. Okay? So if you do understand that, dry run this. This is the program I wrote earlier. Again, I'm trying to write some code to swap the values in variables. Use a table in the way I just did and give me a justification of what it does so you can justify whether this one actually manages to swap the values in x and y around after the values have been put there. And if it doesn't, what does it do? So I'll give you 2 minutes to do that. If anybody's got any questions about anything about this so far or anything else, stick your hand up, or you want me to look at what you've done, or ask if there's the way you're doing things is right or wrong, stick your hand up and I'll come and talk to you about it. However close I can get to you. You've managed to put yourself in a position where I can't get massively close. But does the test in the 5th week affect your grade? Yes, you get 0 if you don't come to it. It counts as 2 grades out of the 7 for your coursework. So if you want an A overall, you want to be aiming to get A's in both parts of the question in that midterm test. There's some flexibility in that you can throw away one of your answers at the end of, one of your grades at the end of term, so you could sort of throw away one of those midterm tests, screw up one thing on it, but at least one of them is going to count towards your final grade. And one whole question will be write a program question, which will be showing you can do the stuff from weeks 1 to 4, essentially. So this, including this lecture and next week's lecture material, possibly, and some of what I do on the week after. But
you know how you changed it there, so that x is now assigned to get a value in another variable. If you change that to just another 3, for example, we've got the order and it'd just be 3 now.
So which line are you saying? Yeah. So if I had x equals 3, which we're not pronouncing x equals, are we? We're pronouncing x gets the value. If we had x gets the value 3 instead of x gets t, that would say put 3 into x and overwrite whatever was there. And if we had x gets the value 2 plus 2, it would turn 2 plus 2 into 4 and then put 4 in. Do the calculation first, get the answer, you've got a value, and then you do something with the value. Okay, everybody should be writing down an answer to this. I'll give you a couple of minutes more. Any other queries anybody's got? So you haven't crossed them out. I would always cross them out, Because if you don't cross them out, you're telling me you don't realise that there's not two values stored there.
But you don't cross out t because...
So you cross out, whenever you put a new value in, you cross out the old value. And it's for your own good doing that, because it just seems like this is so trivial, but you'd be amazed. You know, I mark hundreds of these every year, and you'd be amazed how many people make really silly, trivial mistakes. And especially if you're under time pressure to do it, it's very easy to just look at the wrong column, look at the wrong value in the column. Anyway, y gets 2. Yeah, that looks okay. Yes, though it's slightly confusing that you've written different code next to what you're doing, but I mean that is assuming that's yeah, okay. So yeah, that looks fine. I'll go through it in a moment. Yeah. Yes. Okay. So that's a good point. You know, if you're asking for the value, or the answer, don't just draw the table. Actually, then write out at the end what the answer is. So x has the value whatever, y has the value whatever, and also he's just pointed out t, there's a variable t here as well, so there's 3 things that are given values. So it might depend on the question. If the question asks just tell me what x and y have at the end of this program, then obviously that's all you need to do. But if it just says work out what the answers of all the variables are, then make sure you do say all the variables. And it is quite surprising in tests how often it is that it's not actually clear what somebody's answers is. They've done lots of working, but they never got around to actually very clearly telling me they think the answer is this. So always make it really clear, because if there's several things written on the paper, you know, how am I supposed to know which one is your final answer? So always make that clear. Anyway, let's just go through this really quickly. So I'm drawing a table again. So there's an x, I don't put anything in it. The next thing I do, I'm here now, I create a y, I don't put anything in it. There's a t, I don't put anything in it. Actually, something else that you can do as well is label the lines in the code, and this sometimes makes it clear. It depends on the kind of code you're saying, but you know, let's say we've got up to line 4, so that's L1. L3 creates 3 columns. L4 puts a 1 into x. L5 puts a 2 into y. Line 6 says t gets what's in y, so we get a copy of y is 2, put it into t. That's what happens on line 6. On line 7, x gets the value of t. So that means we lose the old value and get a copy of t put in there, and L8, y gets the value t. L8, y, we cross out y, it gets a copy of what's in t, that's t. And so what I've done there is made it even more explicit that I know exactly what each line's doing. And again, that's just a much clearer answer. And what do I need to write at the end? That x ends with 2, y ends with value 2, and t ends with value 2. Okay. Though, of course, this particular question just said draw a table to work out what this code does. It still makes sense to write out the answer because it's saying to work out what it does. Hopefully I'd write a question more clearly than that and make it clear I wanted the answer as well as the justification. But any time I write a question that says justify your answer, or with justification, or something along those lines, I'm looking for not just the answer, I am very definitely looking for some working that shows me where the answer came from. Okay, any questions about that? Anybody remotely confused? So there are loads of questions like this as well in the work, in the progress sheets, and possibly some in the workbook for you to have a go at. And any program you come across, you can pick out a fragment of it and basically dry run it just for the practice of it, and then run the program and see if you were right.
So for the justification, you don't need to write a paragraph explaining, you just need to show a working, a table.
If you've got a clear table like that, I would take that as a justification. If it says explicitly draw a table, then I definitely want a table. If it just says justify, then it's up to you. If you find it easier to write it out as a series of English statements, then you can do that. And when we get to harder code, sometimes it is easier to do higher level reasoning that just says something like, this is a loop, it does it 4 times because it goes from 0 to 1, and then you sort of just dry run in a table kind of, you know, small bits of it that are, rather than the whole thing. But if I say draw a table, I mean draw a table. But otherwise, you could do both. Sorry, I can't hear. On the register. It's probably there. If it was there the previous week, it should still be there. Add your name to the bottom of it. But actually have a look again and make sure it's not just in a different place to where you think. Any other questions while I'm down here? It's a bit of a destroyed value from last week still. Right. So, carrying on looking at things that are a bit like what we were doing last week, but taking them a bit further. This is a bit of code from last week. So, again, you can look at it and in your head work out what it does. If you were drawing a table of this, you would create a column for age 1, a column for age 2, a column for age 3, a column for average age. You would then put a value in age 1. An input int is a method now, so you go and evaluate that method, it gives you an answer, and puts an answer into age 1. Now put a value into the column for age 2, put a value in the column for age 3, put an answer. Again, this is not just getting a value from a variable, it's getting values from 3 different variables, adding those values up, dividing them by 3, and then putting that answer in there. So it's always values that you get. You work out the right-hand side of an assignment, and it always turns into a single value, whether that's a string or an integer. You evaluate it, it gives you a value, and then you put it in a place. And once we've got the values in variables, we can then use them later, and that's all this is doing. Later on, average age is accessed. You get the value that's been stored in there, the result of the calculation, and print it out with a message. So what is this bit of program doing? It's actually just asking the user for 3 integers, and they're working out their average. Okay? There's a few subtleties that are a little bit further, going a little bit further than things we looked at last week, though. The first subtlety is I have actually declared this as a double rather than an integer, so that means I'm asking for a floating point answer. So this is definitely a subtlety. If what I'd written there was age 1 plus age 2 plus age 3 divided by 3, that would do an integer calculation. So it would take those 3 integers, add them together, and divide them by 3, and essentially truncate and give you the rounded down answer, and then it would turn that rounded down answer into a double to put into average age. What we're doing by putting 3.0 there is saying I want this to be a decimal floating point division to give me a floating point answer. You can also tell programs to convert. If you've got some variable age 1 and you want it to be turned into a double, you could write double in brackets before it, and that says take that integer and turn it into a double. So if what was stored in age 1 was 42, it would turn it into 42.0, i.e. the floating point version of the integer 42. So that's one small subtlety about that, sort of mixing up the the types and doing type conversions from integers to doubles. The other thing is about what actually this method does. So this is actually a method I've written, and I'll show it you, it's on the next slide. But it's a little bit different to any of the methods I've gone through before. So it does return a value, so it must be a method with a return statement. What type of value does it return? Well, we can see that's age 2, and age 2 is an integer, so this is returning a value to put into age 2, so it must be returning an integer. So when we look at its definition, we're going to expect to have a return statement, but that return statement is going to have some value that's a number after it that is what it will return. And in each case, we're storing what it returns as into an integer. It's always got to return integers. So at that level, it's going to be like the things we've seen already. It's a method, it's a bit of code we're going to jump to, do some work, and then jump back, but we're going to jump back with an answer, an integer. But there's something subtly different, because actually, for the first time, I've put something inside those parentheses. When we've called methods so far that we've written ourselves, we've always just put open parentheses, close parentheses. And what this is doing is passing some information that method needs to do its job. And actually, it's absolutely no different to what we've been doing from the start with printline, because printline there is a call to a method somebody else wrote. It's just in the system library, so you've got access to it, but somebody wrote that method for you, and we need to pass it some information to do its job. You can't do a print unless you know what you're going to print. So that method needs to be handed a value, which is the string to print, before it can do anything. So when you execute system.out.println, all of this lot, the first thing that happens is all of that I've put in the box gets evaluated, gets turned into a value. You work out what that value is. How do you do that? You go and look at average age, you get the integer out, you turn it into a string, you stick that string end to end, because it's a plus there, concatenation, stick it end to end to the string the average age of the 3 people is, and now you've got a longer string that's the average age of the 3 people is 43.3 or something, and that whole string is now a single value that's passed to printline, because that's the value, the string you want to pass. Okay? So you've been doing this right from the start, passing information to methods so they can do their job. And different times you call printline, you'll pass it a different value and it'll do a different thing, print a different thing. So what we're doing now is saying, well, we want to write our own methods, like input_int is a method I've written, and we want to be able to pass information to it. Because in the programs you've written so far that have been doing input, if you've done any of those exercises yet, then what you'll have been doing is kind of having a program input age 1, input age 2, input age 3, for example. And so you've written 3 methods, each one would print a different string out, asking it for give me age 1, give me age 2, give me age 3. So now what we're saying is, well, that's a bit silly having to write essentially the same code out lots of times. Why don't we write one method that can do essentially the same thing, which is get a value from the user, but each time we just want it to print a different message before it waits for you to type the thing in. And so what we're going to do is just pass it the message, give it the information of the message we want it to print, it will print it, and then it will wait for the values. So I'm able to use exactly the same method 3 times. Okay? So what do I have to do to make that work? Well, I need something new, a new concept, which is argument passing, parameter passing. And all that is a way of passing information to a method. And the tricky thing about it is, what does the method do with that value? Well, it needs to store it somewhere, so you need a mechanism for it to do the equivalent of an assignment, an initialization, and store it in a variable. So this is all about just a mechanism to pass information to a method, then store them in a variable, and then you can use it in the method. So I'll leave the version of that up on this slide and now show you how I define input_int. What's my definition of that method? Now let's do it a little bit at a time. So the important thing here to start with is the header line. So that first line of a method tells you a lot about the method and what it does. So it's called input int, that's its name. That's stuff we saw right from the beginning. The type that comes immediately before that is the return type. So that says this method will always return an integer when it finishes. Yeah? Public static is just essentially for now saying, well, it's a method that we're declaring, don't really need to worry about what that means, you just put that at the beginning of all the methods for now. And then we've got the open close brackets, and this is where things are different, because everything you've written so far, you've just put open close brackets for the methods you've defined. With one exception for main, you always put something in main, and now we're doing exactly that for all the other, well, for any other method we want to. So what is that string message? Well, it looks like something we've seen already. When we've written string message in programs before, what would we have meant? We would have meant declare me a variable called message that can hold strings. And that's exactly what it means here. All that is saying is before you start, when you call this method, when you jump to this code, the very first thing you want to do is create a special variable called message that is of type string. So all it's doing, just like everything else, is creating a box and giving that box a name, and the name of this box is going to be message. And it's a private box to this particular method. No other method can see it, but it's special in one way. It's there purely to take whatever information you give it when you call the method. Okay? So, over here, when I say input int give me age 1, what does that mean? It means when I call the method, oops, I lost my rough paper. Somewhere or other I've got some paper, oh there it is. So when I call age 1 gets the value input in, give me age 1. That says create a string value, which is just give me age 1. That's a string, it's a value. And what do I do with it? When I call the method, I jump to the code for the method. So if main's over here, we're now jumping over to the code for the method. It's got its own variables, and one of those variables is a variable called message. So whatever it might have been used for before is now a variable called message. And I put that value in. Whatever value you evaluated to that was in the brackets when you did the call is a value that you carry with you when you call the method. As you pass the baton, you're now taking some values with you, and that value goes in the box. Okay, so it goes into message. So what this is essentially saying, if I combine these two just for a moment, is I'm jumping from here down to here, and when I finish this I'll jump back again, but I'm taking with me this string, and the string gets stored into that box there, into that variable. So whatever you put in the brackets here is the thing that gets stored into message here. So on the next line, when I finish doing this and jump back, I'll then call input int again. What will happen is I'll take with me another message. This box will have been thrown away by then, but the next time I call the method, I'll have gone and got myself another box called message, and I've now put a new string in that. So what would be in message this time? Now we're doing the second called age2 gets input in, give me age2. All I've put is the string give me age2 is now the value that I've stored when I've called the method. So all you're doing when you're calling a method, you're passing the baton to another bit of code, but the baton's taking some values with it, and you put the value in whatever variable you declared between the brackets of the definition of the method. Okay? So if we then carry on, the point about that is that value is now there, ready for us to be able to use. So actually let me just swap it for the other thing. We're doing the first call, we're doing age1 gets input in, give me age1. What's in the box is going to be age1. So we've jumped to here. So the first code that gets executed as you jump here is actually to declare a variable, and only then do you carry on with the rest of the code. And what the rest of the code is then saying, oh, create me some more variables. And actually, I probably didn't bring enough boxes this time. So then we've got string text input. All that's doing is saying, okay, we're going to need another box called text input. But text input doesn't get a value in it because it's just being declared, it's not being initialized. So even though that looks like it's just being declared, not initialized, that is a declaration and an initialization. It's initialized with the value that's passed. Whereas this is just doing an initialization. There's no link whatsoever with that variable and any value is passed. It's only the variables that are declared inside the brackets. And you can actually declare more variables in there if you want to pass more things. Then you can just put commas between them and put a whole list of declarations of variables. And then each value you put, or each variable you put there is going to expect another value in the call. So we then carry on with executing this. We'll then create another variable, another box. I don't think I have brought enough boxes. Oh, I have. So we're now going to create another variable, another box. This one's called number input. So I've created that, and that's still empty. Okay, so then we jump to this, and this creates a new scanner, which is some other kind of box. Essentially, it's a variable called scanner, and it's linked to the keyboard. So this is just the stuff we kind of looked at in the first week. We then do system.out.println message. So all this is saying is just a normal print statement. Print whatever is between the brackets. It's just in the brackets I put a variable now. And so what is the value of that variable? Well, I go and find the box message and I look in it, and at the moment it says give me age 1. So what gets printed to the screen is a copy of give me age 1. Message has the string give me age 1, I take a copy of it, that's what then gets printed up to the screen. And having done that, I can now just do the basic stuff about getting the next line. So scanner.nextLine just waits for the keyboard and waits for you to type something and then hit enter. Whatever you typed in will get put in text input, so that gets put in the other box. And then, I can't remember whether I've told you this before, but if you want to convert a string to an integer, you can call a method integer.parseInt is one way of doing this, and it's saying take whatever string was stored into text input, convert it to an integer. That's giving you an integer value, and that integer value now gets stored into number input. So as we're executing those two lines, the first line is just waiting for a number to be typed to the keyboard. So give me a number, 5. So that's a string 5 is stored into text input. But that's a string, I can't do calculations on that. What this method's supposed to be returning is an integer. So the next line of the program doing this says, go and look in text input. So I go and look in text input, it's the string 5, and integer.parseInt takes that and turns it into the number 5, something I can do calculations on, and puts it into there. It's now an integer. And I've got the integer that I wanted. That's the answer, the result that this whole method is supposed to be returning. So now we say return number input. What does that say? That says go back to number input. It's there. Look what's in it. It's an integer 5. Make a copy of that. Okay, so I make a copy, and at this point I make the copy, and the copy is going to be passed back with the baton because this is the return statement. I return. I jump back to the place in this program where we finished. I've just done input in, give me age 1, and that says put that in a box age 1. So now we're back in May. This was May. Oh, no, I've put the average 3 ages. It's something called from May. That value 5 is now going to get put in a box here. And when we've returned, what's happened to all of those boxes, they've all been thrown away. So we return, so the boxes just go back into the general store of memory to be used by anything that needs them. All their values are lost, including the one that we put the parameter in. So when we call it again, we now move on to the next line of this H2 gets input in. We're now going to do that whole procedure again. We're going to pass the baton. In passing the baton, we're taking the value, but now it's a string, give me H2, is being passed with the baton. That's getting put in a new box we create, and then we'll create the other two boxes, and then we'll do something, and then we'll pass it all back with a value. So what it's allowing us is the same piece of code is doing three different things, but they've all got the same pattern. There's just one thing that's different about them. That's what message do you want to print. So we pass that information when we do the call and store it in a variable and then just use it in the appropriate place, which is this line here where we want to print that message out. So whereas if you've done something like this before and you had input H1 as a method and then input H2 and input H3, the code you would have written would be the same 3 times over. You just would have put a different value there. So we replace that thing that's the same each time by a variable, make that variable a parameter, and store the value in it. Okay, so anybody got anything they don't understand about this? Yes? Sorry, when? So message is a variable, it's the name of a box. So what goes in it is not H1, it's a value that's being passed, it's the value that's the string give me H1. A series of characters, G, I, V, E, space, that's what goes into message. When you return a value, you're returning the value that was out of one of the other variables, a different box, and it's that value, that integer value, then gets put in another variable over there, the method that called it, that's the number that went into it. Is that what you were asking? Yeah? So what goes into message, what goes here, is what you put between the brackets over there. So 3 different things go in. Give me H1 goes the first time. When you execute the first line, give me H2 is what goes in the second time, so a different thing will get printed out and so on. Yeah? Yeah.
Just to confirm that, where it says system out print my message, it comes from give me H1.
So when it says system out print line message, what is being printed out? Yeah, is exactly give me H1, give me H2, give me H3, but we're using the variable message as a place to store that string in the place here. So this is the puzzle you probably had from the beginning, is how do we pass information around from one method to another? We've got a value in one variable, but that variable isn't visible, and I've told you can't use global variables. You can't have one variable that every method can see. So the way you do it is this. You pass information from one to the other just by putting whatever you want to be passed between the brackets, declare a new variable over here which captures that value, and then that's the variable you can see over this slide. And when you jump back, you take a value with you and use an assignment to put that value back in the variable over this side that you actually need. Yeah? Okay, another question. Why did I need both string text input and int number input? Because when you do inputs using scanner.nextLine, it's reading a whole line of text. And what you're typing at the keyboard is a series of character presses. Each time you press a key, you're basically sending one character. So what you've got is not a number, it's definitely a string of characters. Even if you type 543, you've got the character 543, the character sequence 543, that's a string. So you've got to take that 543 and turn it into a number 543. And it's an algorithm for converting sequences of characters into actual numbers, and that's what integer.parsint. It's just the algorithm you know about. Well, the 5 means 100, it's 5 times 100 plus 4 times 10 plus 3 times 1. It's just doing that decimal kind of adding up of things being in multiple columns. Yeah, and actually if you go and look in that library, there is actually a whole bunch of different methods. So there is a method that does those two things for you, called something like nextInt. So what I'm doing, I want you to sort of see the steps of what's actually happening. So I've separated it out, but if you go and look in the library, you'll find there's a whole bunch of things that people have written these conversion methods for you that make some of this a bit easier. Okay? So always when I point you towards a library, go and explore the library and find out what else is in it, but make sure you understand exactly what those methods are doing. And here we're doing reading and string and then a conversion. And the nextInt method does exactly that. It probably even calls the same integer.parseInt method. Yeah. So at that point, I'm reading in a string and converting into an integer. So anytime you want to take a string and convert it into an integer, you can use integer.parseInt.
What happens if I type in something else? So
it will.
I find it takes an integer.
Yeah.
If I type, let's say p, for example.
So if you type something that isn't a number, it will crash your program. So all it will do is bail out with a big error message saying, "Ah!" in about 20 lines worth. But that's all it's saying. And what it's saying is slightly convoluted, but it's basically giving you a track of how it basically tried to handle this weird thing that you've just done. And so actually, if you're writing good programs, you would do more than this. What you would write is some code around that would check that you really do have a number first before you start to convert it. Or you do, I said I was clumsy, didn't I? Or you do something that isn't really part of the syllabus. You use exception handling, which is a way of catching the program crashing and say, if it crashes, do something else. And gives you some code to handle so that you don't bail out of the whole program. You just sort of crash locally and then handle it. Yeah?
So how does that compare to scanner.nextInt?
Does scanner.nextInt deal with that? I think scanner.nextInt probably crashes too, but I'm not sure off the top of my head. So go try it. Just do the experiment.
Is this more efficient?
No, I mean, scanner.nextInt is probably doing exactly the same as this. If either is more efficient, it's more likely to be scanner.nextInt would be more efficient because maybe they've sort of done some clever thing of reading in the characters one at a time. So I'm only showing you this not because it's necessarily the best way of doing it, just because you need to know integer.parseInt anyway, because there'll be times when you want to take some other string that's calculated some other way by people sticking strings together or something. So it's just a useful thing to know, and this is one way of me showing it you. And once you know this, you now understand what nextInt is doing. Whereas if I just show you nextInt, then you just accept it as magic and never go and delve under the hood. So one last thing, yeah.
What about if I type int text input instead of string text input?
If you type int text input, the compiler would complain and you get a message along the lines of incompatible types. I was expecting an int and you've given me a string, or vice versa. So the compiler would have a problem with that, and that's the sort of thing the compiler's there to try and catch, because if you've said int text input, you're saying I'm going to store an integer in text input, and then when you do, text input gets the .next line, that's returning a string. So you can't put a string in an integer, and the compiler can spot that just statically looking at your program. Scanner.nextLine returns a string. It's passing back with the baton a string. Okay, any last questions? One over there, and then I'll go on. Shh. Would it work without the string where? Oh, when you want, so if you didn't put string text input, you just wrote text input there. No, you definitely need text input because I'm storing text input, the scanner.nextLine, into text input. You could do it a slightly different way. So what you could write, instead of those two lines, you could write number input gets the value that integer.parseInt returns. And then instead of putting a variable in there, this doesn't have to be a variable between brackets, it doesn't have to be a specific value you pass to methods. It could be just the result returned from somewhere else. So what I could write in there is scanner.nextLine. And what that says is number input gets the value, integer.parseInt returns when it calls scanner.nextLine. So how is this evaluated? Before you can evaluate that, you've got to evaluate that. You always evaluate inside the brackets first. So you execute scanner.nextLine, it comes back with a value. That value is sitting between the brackets, so it's the value that gets passed to integer.parseInt, and then integer.parseInt returns a value that gets assigned to number input. So you can combine those two lines into that one line, and then you wouldn't need to declare a separate variable. So what goes inside the brackets here is any expression that would evaluate to a value. What gets passed and gets put in the box when you do a call to a method is the value. You execute everything first until you're holding a single value, which in this case is whatever scanner.nextLine returns as a string value, and that's the thing that's passed on. So that's a completely different way of doing the same thing. So you can either call a method, store it in a variable, call an X method and pass the value of that in that variable, or you can chain together the method calls, so inside each method call you're doing another method call. But that's a slightly more advanced way of doing it. I've lost track of who asked me the questions. So is that sort of what you were asking? Okay, let me move on now. Oh, actually, let's probably have a break. Let me just have a look at what I was going to talk about next. Yeah, okay, we'll have a break for 5 minutes and then we'll look at how can you declare your own type. So we've seen types of string and integer. What if you want to create some new type of your own? And that's what we'll be looking at next. So I'll start again in about 5 minutes, so that's just before 5 past on my watch. If you go away, make sure you come back in 5 minutes. If anybody's got any questions, I'll stand down here and you can come and ask me questions. You should have been just doing work in your own time. Any programs you've got done, you just bring it to the lab and get a TA to look at it first thing. So there's not a problem, you can go at your own pace, so you just maybe are a bit behind in getting things marked, but don't skip too many labs in a row because we'll only mark so many things at once. Yeah, well, the demonstrators, not necessarily me, but yeah, one of the demonstrators. Sorry, you say that again. Yeah. Yeah. Yes. So every time you do an assignment to a variable, you throw away the old value and put a new value in. You cannot get the old value back unless you stored it somewhere else. It's destroyed, it's no longer stored there. Those boxes can only hold one value at a time, so if you put a new value in, whatever was there before gets lost. Okay? Well, not down to that level of detail, no. So in C++, the same thing would happen unless you're in a completely different situation. But the sorts of programs we've looked at here is the same in C and C++ and Java. There are situations in Java and in C++ where things are more complicated than that, but we haven't seen any situation like that yet. There's a whole library for it, and there are programs on the QM Plus website that show you how to do it. I'm not going to talk about it explicitly in the lectures, I don't think, because it's something you can work out for yourself. I can't remember which unit it's in, but it's in the workbook as well. You know, so just skim through the workbook, you'll find a section somewhere on random numbers. I don't have a copy here, but it's definitely there, and there's some example programs on the web that show you using it. No, it can be called anything you like. And so actually, if you, so the only thing is, it doesn't have to be anything linked to the place that's calling it, is the first thing. But what it has to be is consistent within the method itself. So if you change its name at the top, then you've obviously got to change its name in the print line statement where you use it to the same thing. But all it is a label that says this is the value that we're talking about. This is the thing that we're talking about. It's that you call input int and you put the thing in brackets there, and whatever is in brackets goes with you when you pass the baton to input int. And so the first thing it looks is what is in its brackets, some variable declaration, and whatever you pass just drops into the declaration as an initialization. So it's the things that are in the brackets link up, basically, in the call and the header. Okay? Have you been to any of the labs? Come and see me at the end of the lecture. You've obviously got a vast amount of work to do to catch up. Have you got a welcome pack? So you've got the stuff that's got your ITL building, and okay, and have you actually logged into the ITL and checked that your account works in the ITL building? Okay, I haven't got any with me, but there's some sheets you've got to do that you ought to do in your own time, just to try and catch up with the very first stuff we were doing. You need to come to a lab tomorrow. Do you know which lab you've been assigned to? Okay, there might be a number next to your name on the register. If so, that tells you your lab time. If not, I'll need to try and work it out for you. But basically, I haven't got time to sort it all out now. And if you come with me at the end of the lecture, then I'll take you back and go and find you the desk. Right. In your welcome pack, there's a workbook. That's the workbook I'm talking about. So start reading through that. We're up to week 3 basically now, unit 3 in that. So you've got to catch up as far as unit 3, essentially. But if you've got time tomorrow, if you don't have other classes, you can come to multiple labs to try and catch up through tomorrow by doing sort of 4 hours, 6 hours of labs instead of just 2 hours. To give you more chance to catch up. But come and see me afterwards, because I haven't got time to sort everything that needs sorting out now. Yes. Oh, no. So the return value isn't linked to that at all. It goes back to whatever you call, so it just is the thing that's carried back with the baton, and it stores in age 1 because you need a command in the calling place that says what you do with it. So the first time it goes back to age 1, but the second time it gets put into age 2, and the third time you call it gets put into age 3. Is that, yeah, what you return is nothing to do with the information that's passed. So how does it know to go to age 1? Because this line here says age 1 gets the value that input returns. So so the last line of the method input in says return what's in number input. That says go and get the value out of number input and bring it back. And this says age 1 gets whatever you brought back. It doesn't go into message. Coming back is nothing to do with message. Message is only about passing information that way. When you're coming back this way, you return and you're holding the value, and you've got to have a command here that says what you do with it. So the first line says whatever you come back with the first time, put into age 1. But when you call input in the second time, it's now saying whatever you come back with, put it into age 2. Yeah, so it's always returning a value and putting it where that command says to put it. Yeah? Were you at the front of the queue? Yeah, were you? Because let me just do things in order. If you don't put 3.0 and you just put 3, it will treat that as an integer division, and integer division gives you an integer answer. So if you said 4 divided by 3, you would get the answer 1, not 1 point something, because it's giving you an integer. It's already thrown away that other information about what was after the decimal point. So if you've got divided by 3, nor is saying give me an answer that actually is a decimal answer. You don't throw away the decimal point. So it's still there when you put it in. So even though average age might be a double, if you didn't put 3.0 there, it's already thrown away the information before it even tries to put it in stuff. So it depends on what the exercise is asking you. But yeah, I think for the early assessed exercises, I wasn't expecting you to know this. So integer results are fine, and my answers are all integer results. So it's okay. But you might want to now go and try this. I don't care. It's what I'm looking for. But you really ought to practice your spelling and get better at it. The more you try, whatever is the reason behind why you can't spell, the more you practice spelling, the better you get, like any other skill. It's because it doesn't fit on my slide if I don't. But you can do it. You would only do it with variables that had some close link. And in this case, they're all doing the same thing, so actually it's not a bad program to do it like that. Okay? No question, stupid. You can now, as long as I'm talking to other people. So you can have integers, which are whole numbers, and you can have floating point numbers, which are numbers that have got a decimal point in them, and as obviously more accurate, you've got values after the decimal point. So if you declare something double, you're declaring it as being able to hold things with decimal points. If you declare it as an int, you're saying it will only ever hold whole numbers, so throw away decimal points. Yes, essentially. But it's a bit more subtle than that in that you might have to, you've got to make sure the thing you're putting in gets converted, and you might get the compiler complaining in some situations that you didn't convert it first. So that's generally the case, but there is a bit more subtlety to it than that. But that's really what ultimately is behind it all, yeah. Okay? Very last thing, because I really want to get on. Yeah. No, it's inside the class. I'll show you. Oh, maybe I haven't got a slide that shows you, but yeah, all the methods are inside the class. So you have class, foo, open brackets, close brackets. Methods are inside those open close brackets, the very outer open and close brackets. And they're just methods one after another with their own open close bracket. You can't embed one method inside another. All methods have got to be inside a class. Okay? Right, shut up! Okay, so let's get going on something completely new rather than just new things linked to last week. So Java gives you these whole bunch of types that we've seen so far, like string and int and boolean and char for character, and they're existing already. They're sort of fundamental types. Sometimes you want to create your own types, and Java gives you a very simple mechanism for doing this, which the general concept of this is called a record. So across other programming languages, they're called records. In Java and other object-oriented languages, this is actually the first step to doing something vastly more powerful called creating objects. Okay? But I'm not going to get into that, so we're just going to look at a very simple way of using these, that will actually give you a stepping stone to understanding later things. So what I'm describing here is essentially something that works across a whole range of different procedural programming languages. When you get into object-oriented languages, then it's a different way of programming, and you can actually do more powerful things. So the idea is, suppose what you wanted to do was create a type in your program, not of strings or integers, but of something that's actually a bit more meaningful, like a student. So let's suppose I'm creating a student database for all your exam results and coursework results, because I've got to get this sorted soon, because in 2 weeks' time you're going to be all doing a test and I'm going to have to record all of those marks. So I need a program to actually help me record the marks. And so what do I need? What do I think of as a student? Well, maybe it's a person like you lot, or maybe it's just a bunch of data. And what is a student to me, really? Well, a student is a name, it's a student ID, and it's a mark. And that's all you really are, as far as I care about, come exam time, anyway. And so what I want is a program that can treat me, or allow me to process things like that. So just like a string is lots of characters, what we're saying we want a student to be is a bunch of separate values. And what this comes down to is essentially what can we store in boxes, in variables. So I've said so far, variables can only hold one thing. And sometimes that's a bit of a pain, because if I'm creating stuff about a student and I've got lots of bits of information, their name, their student ID and their mark, then I'd have to put them in 3 separate boxes. So what this essentially is, or another way of thinking of it, is it's a way of taking separate boxes, maybe of different shapes and sizes, and gluing them together. So let's glue them together like that. So that actually what you've got from behind is it's just one box. It's just a bigger box, but it's a box that's now got compartments in. And what I want to do is give a type, so declare what I mean by a student. It's something like this that's got a string, and an integer that it can store. But I've actually can think about it as being one box, just a box with lots of compartments, rather than a single box with only one compartment. And actually this is exactly what strings are. Strings have lots of compartments for each separate character, but you don't get to see that. And so this is all about hiding the detail of what you're actually storing, but making the program appear so you can write the program so you're dealing with the objects you're actually thinking about, the things you're thinking about. I'm thinking of a student. I don't want to separately think about a student mark and so on, and a student name. I just want to think about the student. So, how do you do this? You actually use the class mechanism. So you've been writing class student so far as being the name of your program. What we're saying now is you can write lots of extra classes, and those classes are actually templates, blueprints about what type you're trying to create. So it looks like you're declaring variables here, but actually what these are now in this situation, using the terminology of records, is they're actually field names. They're the names of the compartments of the values. So this is essentially saying, whenever I declare a type of student, what I want a student to be is something with 3 compartments, one compartment that's a string with a field of name, so I'll refer to one of the compartments as the name compartment, one which is a string which is an ID, and one which is a string which is a mark. So essentially what it does is says what students look like are something like this, that they hold an int, a string, and a string, and I'm kind of giving them names of .name, .id, and .mark. Okay, and I'll get back to what I mean by the dot in a moment, but if you think of the names of the compartments are always going to be the mark compartment, .mark, .id, and .name. And what this is doing, it's not creating any actual student, it's just a blueprint. It's like a way of printing, a way of creating students. When I want a new student, if I don't have enough students, I can just create another one, and this is the mechanism that tells me, the blueprint that tells me how to create a new student out of nothing. Okay? So, how do you use that? Let me actually go to a whole program and put it all into context. So, this is now a whole program, but it's now got two classes. So that part is just what we've been looking at so far. Everything you've looked at so far has been a class like that. So a class is, the first class is basically giving you the name of the program. When you do Java student record, you'll execute this program. It's the one that's got main in it. And what is a class is just a series of methods. So each method that you have would just be inside those curly brackets. All the methods are in between the curly brackets of the program class. But what I'm now saying is you can add a class on the bottom, which is a template for a record that you're creating. Okay? So that's the same as we just looked at before. Let's look at how we're using it. So the first thing to see is this part here. So there I say student S1. That's exactly the same as saying something like string S1, or int S1, or int M, or string message. It's a type followed by a name of a variable. So what I'm saying there is the type is student. So what I want to create is a student. Actually, let me put the same thing up here. So what I want is to create a new student variable. I'm creating a box of type student, and it's going to be called S1. So that's its name, S1, and it's a type student. And so all I'm going to do is, when I execute that line, I'm going to get a box, and it's got to be a box that's the right shape and size to hold students. So that doesn't mean a box like that. It means a box where I've essentially stapled bits together. And when I say student S1, I'm creating a box that from the front just looks like a big box, but inside is going to have compartments. And this whole thing is called S1. So essentially, when I'm doing that, I'm essentially saying I've got one single box with compartments in that I can put information into. And how do I put information into it? Well, I use the field names to put information in. So the name of the variable is always S1. So I say S1.name gets the value Paul Curzon. What does that mean do? It means each of these compartments has a name. It's the name combined with, or the combination, its name is the combination of the variable name S1 and the field name. So one would be S1.name, one would be S1.id, and one would be S1.mark. So the whole thing is called S1. It's just a single box called variable S1. But if I want to get to it, an individual compartment of it, I use S1.name for that compartment, S1.id for that one, and S1.mark for that one. So when I execute that first line, S1.name gets Paul Curzon, I'm creating a string Paul Curzon, and that says S1.name gets that. So I go to S1, and that's the whole thing, and the .name then says which compartment of S1 I'm interested in. It's the S1.name compartment, and that's where I put Paul Curzon. So I've now got this whole thing has got three compartments. One compartment in it's got a value, and the other two compartments are still empty. But then the next two parts do the same thing again. The next line says S1.id gets the number, whatever my student number would be, 45009930, which happens to be a string. And that goes in there, and then the next thing is S1.mark gets an actual integer, the number 89 as opposed to the string 89, and I put that in there. And so what I've got is S1 now, actually, despite what I've been saying, variables can only hold one thing at once. If you make a special variable that's got lots of compartments, then each compartment can hold one thing at once. Of course, if I now put something new into one of those compartments, exactly what I said before still happens. If I put a new value of 72 into the mark value, the old value would be torn up, eaten, thrown away, just like it was before. So we can actually hold multiple values because I've created a special type to represent students that has lots of parts to what that value means. It's a value that's a complicated value with lots of separate bits to it, just like a string is a complicated value with lots of characters connected to it. So once I've put values in, I can then get them out using this notation s1.id, s1.name and s1.mark again. You can sort of think of those things as a special name. So essentially, when I declare student s1, I'm not creating one variable name. I'm sort of creating three connected variable names, s1.name, s1.id, s1.mark. How do I know what the three variable names are? That's what this blueprint is telling me. I go down to here to look at the blueprint, and it says what kind of box I'm needing and how I can refer to each separate compartment of it. So what this is doing is a very simple way of creating a new type of student. We're creating a variable of that type just in the same way as we create any other variable. Now we've got the type, and we're putting things in and getting the values out just in the same way as we were using the name in the appropriate place to put things in or get things out. So nothing about this is really any different, apart from the fact that you need to know both the variable name and the field name, the compartment that it's in. There's one other thing, which is the initialization of this. This actually says student S1, but then we've got gets the value new student. That's actually creating a new value, and it's actually essentially the same sort of thing going on that we've seen already, if I can find something that I've got it on. Oops. So compare that with scanner equals new scanner, and student S1, oops, can't fit them both on at once. So it's the same thing we're doing, scanner, type, variable name, gets the value, new, type, and then brackets. We're doing the same thing here, type, variable name, gets the value, new, give the type again, put brackets. And what does this do? It is essentially the thing that goes and gets the storage, creates enough space, creates the right shape and size variable in memory so that you can actually store values in. It's not putting the values in, it's creating the memory space. We'll talk a lot more about that in a later lecture towards the end of the module about exactly what's going on when you do new. But essentially, you can think of the first part of that, student S1 is creating the variable, but it's not quite sure at that point where in memory it's going to store it, and the new goes and gets some storage of the right shape and size so that you can start putting values in. Okay? So, any questions about what's going on there? No? Okay. So, let me just tidy the slides up a little bit and put another slide up just to sort of emphasize the point. So now this is just a bigger program that's doing essentially the same thing, but here what I've done is declared at the top two variables of type student. I've created a student that I've called S1 and a student I've called S2, and then I'm doing the same thing. You know, the first little block of code is doing exactly what it was before, storing the details of student 1. It's Paul Curzon with a number and a mark. Very good mark, actually. And then another student storing variable S2 with a value of a name, its ID, and its mark. And then I can access each of them if I want. The first student, that's S1.name. If I want the second student, that's S2.name. They've both got the same field names because the field names come from the class definition at the bottom, but I've given them separate variable names so I can tell them apart. But it is no different to anything we've done so far, apart from the fact that you've got multiple values that you're storing. And basically the class definition is sort of fixed. You know, when you declare a student, you're always going to get something that follows the blueprint in the class definition. with those fields. You can't have students sometimes having 1 mark and sometimes having 2 marks. Okay? So everybody with me? One question, yeah?
Why do you have to do that instead of create just 2 methods called student 1 and student 2?
So it's not methods that we're creating here, it's data storage. So methods are instructions that do something. Here what we want is storage space. We want a variable that can hold a particular kind of thing. So it's the difference between the instructions to do something, i.e., the commands to store values into variables, versus defining what the variables look like, how much space they've got.
But the result is the same. So if I create a method like student 1 and with all the details, and student 2 with all the details, the result is the same.
You could get something similar like that, maybe, but it wouldn't ultimately be the same because we'll get to later ways of creating arrays of data where actually you can create vast numbers. We could have 1,000 of these students and we'll just declare do one line of declaration that says create me 1,000 students. Your way, if I understand what you're kind of saying, you would have to have a specialized method for each student, and you don't want to do that because I've got 430 students here. I do not want to write a program where I've got to write a special method for each student. So we have a general method of creating students, and then we can use that general method over and over again. Okay, but what I'm about to show you is methods are a really important thing here to make this work better. So that piece of code is actually not very well written. It's a very simple way of writing stuff, but actually this way of using the dot notation to access things in a record is not really very good programming, because what you want is to actually add a level of indirection to it, a level of abstraction, so that you can make change to programs easily. So let me just show you what I mean by that. And this is using something called getter and setter methods. So that's what we're going to talk about now, getter and setter methods. And it will use what I was talking about before, about returning arguments and passing information. So in object-oriented languages, getter and setter methods are done in a particular way. What I'm showing you here is that you can do the same thing in procedural programming languages. So those of you who've done a bit of object-oriented programming, if you've done some Python, you might have come across getter and setter methods before. It's essentially the same thing that we're doing, but I'm showing you how you can do it in a procedural programming language. Okay? And if you don't know about getter and setter methods, don't worry about that, because that's something you'll find out about later when you do an OOP course. So, the point is, methods are actually really powerful as a way of accessing things and of giving a sort of barrier and abstraction that hides some of the details about the implementation. So when we're doing small programs, this doesn't seem like it really matters. When we're writing 1 million lines of a real student database, like Queen Mary's student database, that system is presumably absolutely massive, the MISIS system. And if we're writing code that big, we've got to have ways of breaking things down into smaller chunks and making it so if we want to modify one part of the program, we don't have to modify everything else. And that's why I was telling you not to use global variables, for example. You're trying to localize things so that you only have to change things in one place. So what's going on here is that class, that definition, is essentially fixing the structure of a record. And if I start using this .id notation, then essentially I'm going to end up that if I wanted to make changes to what I meant by a student, I might have to change it in lots of places. So let me just get this onto the same slide. So what you do is for each of the fields, you write a pair of methods that access the value in that field. So there's two things you want to do to a record. You want to put a value into a particular field, and you want to get a value out. So that's why it's getter and setter methods. We write a method whose sole purpose for a particular kind of record is to put values into a field and to get values out of the field. And it turns out this is a really powerful thing to do, and I'll tell you a little bit about why it's so brilliant right now, but most of this will come back to later in a few weeks' time when you know a bit more, and then we'll see even more about why this makes programs so much better. But what I've got here is two methods, and I'm just going to add these to the class at the beginning along with other methods. So inside the class where the main method is, I'm just going to add some more methods. And these are the ones for the name field. So this is how am I going to access that particular box of any student record I create. So not just one, but every single student record. So I create a method called getName, and its whole purpose is just to give me the name of a student I pass it. So notice I've put a variable in the brackets, student S. So that's doing what we were just seeing. That's saying whenever you call getName, you'll give me a student, and what it's going to return is the name of that student. So how will I get students? I won't, in the rest of the program, use the dot notation. I will just use getName and say which student I want to get the name of. And what it will return me is a string that corresponds to the name. So the whole point of what getName does is it will go to the record you named. This one's called S1, so I will call it with getName S1, and it will go to that, and it will find S1's name, take a copy of what's in there, and that's what it will return. So in this case, what I find there is Paul Curzon. I'll return Paul Curzon as the value that it returns. So it's using the dot notation to return S.name is the thing it returns. Go to S, look in it, find the name field, get the value in the name field of S, and return it back. Similarly, setName is doing a similar thing. Here, in the brackets of the header line, there's two variables declared. So that says when I want to set a name, I need to be given two things. I need to be given the student that I want to change, that I want to set the name of, and I need to be given a string, which is the new name I want to put in there. So if I want to change my name, so suppose I change my name to, I don't know, Ringo Curzon or something by default, and so I want the student record system to change my name from Paul Curzon to Ringo Curzon, then what do I have to do? I would just call this method setName. I would give it the student, whatever it's called, S1 it might be. I would pass it S1 and I would give it Ringo Curzon as the new value. And what does it do? It goes to the field S.name and puts the new student name that I've just been passed into it, and then returns the whole student back, so we've got a new student record that is the thing we're passing back. Okay? So its job is to be given a student and a student name and to give back a whole new student that's got that new details in. And so for each of these fields we do the same thing. We create one for the name, one for the ID, and one for the method. And so what you then get is that your program before, so this is the equivalent of the program that I was just did originally. So what I'm replacing is here. So here I said s1.name gets Paul and system.out.println s1.id s1.name. Now I'm going to use the methods to do that instead. So what I have here is I want to set S1 to be Paul Curzon, so I say set name, it's S1 I want to set, and I want Paul Curzon to be the new name of it, and it will return me the new record that's been updated, so I'll store that back into S1, just keep it in the same variable that I had it before. You can then do the same with set ID, so assume I've written a similar method for set ID and one for set mark. And notice here, I've decided set mark, you're going to have a coursework mark and an exam mark. So for set mark, I'm doing something slightly different. What we're going to store for a student is just their overall total mark, but I'll allow you to pass it the coursework and the exam mark separately. Okay, I was always better at exams than coursework. So we pass those two values, and that gets put into S1, and we pass back a new value of S1 to override. Okay? And then, when I want to print them out, instead of saying S1.name, I can just get the name, get the mark, and get the ID. And notice here, get mark is going to be getting the total mark because we only store one mark. So how does get mark actually work? Let me leave that one up there and put this up here. So when I'm getting a mark, all I do is I'm given a student and I return whatever I've stored in the mark field. But to set a mark, I'm going to be given a coursework mark and an exam mark, as well as the student I want to change. And what I'm going to do is store as the mark for that student the addition of those two marks. And that, by doing it like that, that single method now in this program tells me how to combine marks. So it's not that elsewhere in the program I could do it one way for one student, one way for the other. I've got one single place in the program that is in that method that tells me how you set a mark given the coursework mark and the exam mark. So if the weighting changed so that an exam mark was worth more, for example, all I'd have to do is change that calculation to make it not 50-50 but 60% of one and 40% of the other, or whatever. So I've localized where I have to sort of do the calculations for different marks. But essentially, what we're doing is just providing these two methods to go with each field of the record, and they give us an interface into the record. So the rest of the program now doesn't use the dot notation, only these getter and setter methods use the dot notation, and everything else in the program just calls the methods. And that means I can change this and the way this is implemented, and it would then work for everywhere else in the program. One small change in one small area, and consistently I change the whole program, even if it's 1,000,000 lines long, because everything else in the program is accessing this. And that gives us the sort of power of changing things. So let's suppose that I then wanted to change the record implementation. So suppose the client, so I'm providing Queen Mary with its student information system, and Queen Mary come back to me and say, oh, what we've decided is we no longer, like we said originally, we don't want to just give students their total mark on their transcripts anymore. We've decided what we want to tell them is both their coursework mark and their exam mark and the total for any module that they do. So can you change your student information system so that it actually stores both parts of the mark now, not just the total? Okay, and so maybe, my 1,000,000 lines of program, if I'm not careful about the way I've written it, I've now got to trawl through all of those lines of code looking for places where I have to change to deal with this particular thing. And what do I ultimately need to do is they're saying every student now has to have 2 marks recorded for it, not 1, a coursework and an exam. Essentially what I'm saying is I need a new record definition that stores Mark 1 and Mark 2. So a student now is going to have a name and ID of Mark 1 and Mark 2. Essentially, I'm now going to have a slightly bigger box to store things in. So I'm changing my program, and that is a new class that I'm replacing for the old class. So I've made one change to the program, and now I've got to worry, where else in the program do I have to change to make sure it all still works, and that I'm not going to do things wrong? Well, if you've used getter and setter methods, you can get by with this change just by changing the getter and setter methods for marks. So now we're storing both marks. Well, that just means my setter method for marks, it was given the coursework and the exam mark, and so now instead of working out the total and storing it, what I need to do now is just take those 2 separate components and store them into the 2 different fields for the mark. So here I've got 2 fields for marks now, a coursework mark and an exam mark perhaps, and here I just take the 2 marks, and instead of adding them together and storing a single mark, I just store the 2 separate marks, and then I return the whole student record back to whoever called me. And now the getter changes, so now the get mark, I'm assuming that's still the get total mark, and now because I'm storing the values separately, get mark given a student just has to return the sum of those two marks. So now I've just switched where I'm doing the calculation of how you work out the total to the getter method rather than the setter method. But I can change those two methods, and because the interface to them is exactly the same, the values they need, what they return, and their name, essentially because the header line of them is no different to the version I had originally, the whole of the rest of the program works. I can substitute those two methods in for the old methods, and everything else in the program works. What does the rest of the program look like? Well, it just looks like the one I've got up there, because even though I wrote that for a class that was slightly different, you call set mark with two marks, and you don't really care what happens. All you know is those marks are somehow stored in the system, and when you print them out, when you get the mark, all you want is the total. And in both of these implementations, exactly that bit of code works. I don't have to change that at all. And for big programs, that might be a million lines of code I don't change. I change the record and I change it in two small places. Okay. So we'll come back to this in a few weeks' time, but for now it's just a very simple way of using methods. But if you do write records, you should always write getter and setter methods to go with them, so that the only place the dot notation is used, where you actually access the compartments, is in the getter and setter methods, and the rest of the program just calls the methods. Yes? Well, we haven't done if-then-else statements at all yet. I'm about to do that, talk about it a little bit in the next 10 minutes. So rather than combine that with this, ask me that question at the beginning of next week, maybe. But it's no different to actually doing anything else with if-then-else statements. One other quick question? Yes, okay, so that's back to the thing that I said before. If you're doing object-oriented programming, you can do much more powerful things. What I'm describing here is something that works in any procedural programming language as well. So getter and setter methods as an idea was sort of developed in tandem with object-oriented programming, but this is a way you can do it in procedural programming languages. So if you were doing this in Pascal or C, for example, you can't put anything in the record definition other than the field names. In object-oriented programming languages, you can, and what you're then doing is turning it into an object. And so what I'm doing is taking you one step towards being able to create things that are objects. So for now, humour me and do it this way, because if you practice doing it this way and make sure you can do it this way, you can now use exactly this principle if you're programming in C or Pascal or other procedural programming languages. And actually, there's a whole series of different styles of programming, and I'm going to step you through two of them. So this style of S1 gets the value set name, and so on. In about week 7 or so, I'm going to show you another alternative that, again, is moving a step further towards the way object-oriented programming does it. This is a functional style of programming. So there's another paradigm that's not object-oriented programming, functional programming, and what I'm showing you here is actually something that helps me in a few weeks' time tell you a bit more about what functional programming is. Okay? But when we've learnt a bit more, we'll see actually you can make a tweak to this style of programming to a slightly different style that some people like me think isn't actually a very good style of programming, but a lot of people do it, and it is the basis of object-oriented programming. So yeah, if you've done some object-oriented programming before, you can do it in other ways, but I'm not going to tell you about them. Yeah. Hang on, you'll have to shout because there's a train going off underneath you. So the setter and getter methods are just these methods that are just normal methods, and they are just normal methods that you can put in the class that you've got the main method and any other methods you're writing. So for now, all methods you write go in that single class that you write at the beginning that starts with the main method. All of the methods go in there. And what I'm allowing you to do now is to write only one kind of thing outside of that class of the whole program, which is new classes that have just got fields in. The field names, incidentally, in object-oriented programming get called something different. They're called instance variables, and there's a lot more you can do with them once you think of them as instance variables. But you can't do that with procedural programming languages. Okay, any last question? Because I want to say a little bit about if-then-else statements. And then I'll come back to if-then-else's tomorrow, next week. Right. So one of the things about the programs we've seen so far is they may jump to procedures and jump back again, but essentially you're just executing code one line at a time. So you're just doing a line and then doing the next line and then doing the next line. You might jump somewhere else and jump back, but every time you run the program, you execute exactly the same instructions in exactly the same order. There's nothing ever changes about which things you execute and which don't. Now, absolutely any realistic program you write is almost certainly going to need decisions to be made, so that you do one thing in one situation and something else in another situation. So if I was doing a sort of student information system that was allowing you to find your timetable out or something, you could imagine what you would do is it would ask you what course are you doing, and you might type in G400 or computer science, and what it would do is then tell you, oh, your timetable is on Monday you do this, on Tuesday you do that, and so on. And so what it's doing is looking at what you typed in and then executing some code that goes with it. If you typed in that you were doing electronic engineering, then it's a different set of things it's got to tell you, so it might jump to some different code because you've got a completely different structure of doing electronics labs rather than programming labs or whatever. So you're doing different things. We essentially want to write different code in different situations. So here are some more examples. Perhaps you're writing a cash machine program. So it's going to ask you, do you want cash, or do you want the balance, or do you want to top up your mobile phone, or what do you want to do? And depending on what you choose, it's going to do something completely different, so it's going to need different code. So this is completely standard. So if we're going to invent a language that makes it possible to do this, essentially what we need is something that can ask a question that's, what are you wanting to do? And if the answer is one thing, we want to execute one piece of code, and if the answer is something else, we want to execute a different piece of code. And the way you actually do this in programming language is something called an if statement. So I'm just going to put up an example and give you a brief outline of it, and we'll go through this in more detail next week. But let's stick to this. What do we want? Let's go back a moment. Let's just look at the form. So what we want is something that allows us, say, to execute two different sorts of instruction. So sometimes, perhaps if you're a computer science student, we want to execute those instructions, but if you're an electronic engineering student, we want to execute those instructions to give you completely different information and advice. So what we need is some way of saying which of those two bits of code we want to execute. And so that's what we need, some kind of test. So we need to invent some structure of programming construct that says what's coming is a question, and after the question there will be two different bits of code, and either we want you to execute that bit of code and then jump to the end, or we want to execute that bit of code and jump to the end. So the first thing we need is actually some special keyword, some special word that says this is what's happening now. And that's what the word if is used here. It's a keyword. All that means in a program is what's coming is one of these branch statements that's going to split the code, that you'll either execute one bit of code or the other. You then, again, we're putting things in brackets, but this isn't now a method call. This is, inside the brackets, is a question. It's a test that will have one of two answers. it will either be a test that's true or a test that's false. The answer will be true or the answer will be false. If the answer's true, we're going to want to do that instruction, and if the answer's false, we want to do that instruction. Okay? So how do we split up these instructions? We're using curly brackets. So the curly brackets, just like they were showing where a method starts and ends, here they're showing where a block of code starts and ends that is either the block to do when this test is true or when it's false. So this is saying, if that test is true, do that block of code between those curly brackets. If that test is false, then do this block of code between those curly brackets. And again, we've got another special word, else, in the middle, and all that is a special keyword that means we're dividing, splitting up the two bits of code, the true bit of code and the false bit of code. Okay? So that's the general structure we've got. So if we want to do this, we need some way of indicating to the program, this is the kind of thing we're doing. We're doing a split here. We need a test that tells us in what situation to split, and then we need the two separate pieces of code and know exactly what they are. So now going on to an actual example. So here I've got exactly that structure. What I've got is the keyword if, and in the middle the keyword else. I've got some matching open curly brackets there and some matching open curly brackets there, and I've got a test there. Now what's in the curly brackets is just instructions like you've seen so far. Method calls, assignments, declarations of variables, everything you've put inside curly brackets so far, you could put inside those curly brackets. It doesn't have to be just one instruction, it could be lots, and likewise for those curly brackets. But the way this code gets executed is you start at the top, and when you hit the if statement, you evaluate that test, which will either be true or false, and if it's true, you do that, and then when you finish, you jump to the end of the if then else statement, which is given by the curly brackets. The alternative is it's false. If that test is false, then what you do is you jump to the else statement and execute that bit of code, and when that's finished, you jump to what comes after. So there's two routes through this code, even though they're written on a straight line on the page. Actually, what they look like in reality is something more like this. And I'll go through exactly what goes in a bit more detail in a moment. But we start outside the if statement. We've just got a thing that says, declare a variable ans and get me a string to put in it. And then we hit the if statement, and the if statement splits in two directions. So we've got a question, is the thing that they typed yes? So that's either true, either the thing they typed is yes, in which case it's true, you go one way, or if the thing they typed was false, then you go the other way. You execute whatever code was in the curly brackets in one of those two branches, but at the end you come back and carry on. So at the bottom here we've got some instructions that are not in either of the curly bracket groups, and so that's the code that you join back together with and carry on with the rest of the code. So we've essentially split in two, gone two ways, joined back together, and then just carry on as though we hadn't split at all. And I'll talk a lot more about that next week, but that is a very typical example program that you might have of an if statement. And the only subtlety I've not really talked about is this ans dot equals yes, the thing that's a question. That's, in this case, is just asking, is what's in the variable equal to the string yes, true or false? And go one way for true, one way for false. I'll talk a lot more about that next week, and we'll also look at for loops next week about repeating code. That means you didn't sign the register once. Well, it may be a mistake in the person who was typing it in for me. If you've only missed one, it doesn't matter. Nobody's going to do anything of one miss. It's only when they get up to lots of miss, people are going to want to know why. So if you're not going to miss any more, I wouldn't worry about it. But it's more likely that is you did forget to sign a register, either a lab or a lecture. Yeah. No, you've got to sign my piece of paper. If you did not sign my piece of paper, well, that's going on pieces of paper, so it basically means you didn't sign a piece of paper. Every year people claim this. Every year in the past I've taken them back to my office to look at the signature sheets and we failed to find their signature. You may be an exception of one person who doesn't fail to sign registers, but in the past every single time somebody's claimed that, they were wrong, not me. But it doesn't matter, so don't worry about it as long as you don't miss lots.
So I have another question. The model.
Can I just pack up and you asking me as we go outside? Because the next lecture's got to come in. Anybody wanting to ask questions, I'm going to go out the back and I'll only answer them outside. So form a queue out in the foyer. And I need the registers back.